My name is Alec, and this lightning talk is designed to give you an introduction to web animation. We'll be focusing primarily on the CSS animation and transition properties. I'll break down both of these in detail, discuss performance and efficiency, and talk a bit about different use cases for animation. At the end of the slides, I have a few interactive challenges prepared, so mute yourself on Zoom, grab some popcorn, and follow along. In the context of the web, animation simply means bringing your page to life. For example, a button with a hover effect, a spinning loading icon, or a menu sliding in and out of the page. These are all examples of animation. Animations can serve many purposes in your application. You can use them to guide users around your app by drawing attention to important features. Data visualizations often use animation to help users understand raw data in a logical and readable way. Animations stand out, they draw attention, and they're a really fun way to improve your user interface. Let's dive into the two CSS properties that are used to add animation to your app: transitions and animation. First up, transitions are the simplest way of animating a DOM element. A transition is simply specifying how a CSS value changes over time. There's four components to a transition. Transition property is just the name of the CSS property you'll be changing, such as color or opacity. Duration is how long the transition will take to complete. Delay specifies how long to wait before starting the transition. And then transition timing function is the speed curve of the transition. And we'll talk a bit more about timing functions in a few slides. It's important to know that these four properties can be applied as separate rules in your CSS style sheet, but they're often strung together under one umbrella property, simply called transition. Let's take a look at a simple example. Here we have a square with a transition rule on it. The transition says that any changes in opacity should span 2 seconds. You'll notice here that we're only specifying the property name and duration. If we wanted to change the delay or timing function, we can simply tack them on after the duration like so. Now that we're all set up, when the square's opacity changes, it will fade out over 2 seconds rather than suddenly disappearing. Now let's look at the animation property. Animations are similar to transitions, but allow you to create more complex changes. To define an animation, we use the special CSS rule @keyframes followed by the name of our animation. This name will be referenced later and triggers the changes that we specify inside. It's a lot like defining and calling a function in JavaScript. The basic idea of an animation is to specify starting and ending values for each CSS property you want to change. You can also specify in-between values as demonstrated with percentages in the example on the right. Both the to and from and the percentages are valid syntax. So on the right, this rainbow text animation will flow through each of the 6 colors over the course of the animation. Once we have our keyframes, we can now apply our animation to a DOM element. This should look familiar, as it's quite similar to the transition property we just saw. The key difference here is that applying an animation will trigger the changes immediately instead of waiting until a property value is changed. Like transition, animation has several components to it, which can be defined individually but are often strung together on a single line. Animation name, duration, delay, and timing function will be familiar already. The new components we see are iteration count, which is the number of repetitions that will be executed, the direction, normal or reverse, and the fill mode, which helps the browser know what styles to apply before and after the animation is complete. Let's take a quick look at timing functions. Timing functions are important to be aware of, but can be a bit daunting starting off. There's a lot of them. A timing function essentially determines how fast your animation runs. And the default value is ease, which means it starts slow, accelerates in the middle, and then slows back down again at the end of the animation or transition. Another common value is linear, which, as you might expect, has a constant speed throughout the animation. You can customize these timing functions quite a bit to achieve unique and interesting effects, so I encourage you to look into them if you're interested. There's a lot of useful tools online to help you choose the right function, and I'll include a link at the end of the slides. All right, let's talk about performance and efficiency. Because much the same as when you're writing an algorithm, animations should always be developed with performance in mind. For CSS animations, there's 4 main properties that the browser can animate cheaply: position, scale, rotation, and opacity. And note that the first 3 all stem from the transform property. Transforms are a lot more efficient than animating something like width, height, margins, padding, because they're calculated in the final step of rendering before your browser updates the pixels in your browser window. This final phase where the transform and opacity are calculated is called the composite phase, and so sometimes these properties are called composite properties. This screenshot from Chrome DevTools demonstrates how the browser calculates and renders CSS. In the layout phase, in purple, the size and spacing of all your elements are determined. Since these properties affect the layout of the elements around them, they're actually some of the least efficient properties to animate. But then the further you go down in the diagram, the more efficient they become because fewer changes need to be calculated in order for the changes to actually be seen on the screen. So while it's certainly possible to animate other CSS properties, and in fact we'll be doing that in a little bit ourselves, you should be careful which ones you choose because some of them can cause performance issues, lagging, choppy animations, especially things like width and height. You should always stick to using a transform. Okay, and we've been talking about CSS this whole time, but what about JavaScript? I just wanted to mention a few JavaScript methods that are often useful when working with CSS animations. And first up, there's a few animation events that can be useful to listen to. So taking an example, let's say you have a list of items where you can add and delete from the list. And then when an item is deleted, you want to slide the item off screen and rearrange the remaining items to fill in the gap. Usually in your JavaScript, your delete function is going to remove the item and its data from the list instantly. And then without that data, your DOM element might disappear abruptly or might show something like undefined in the title, something like that. And the solution here is to listen for the animation end event and pass your delete function as the callback. This ensures that the item's data sticks around until the animation is completely finished, resulting in a much smoother experience. Next up, we have a way to play and pause your animation using animation play state. And then finally, getComputedStyle is a useful way to track the exact values of your CSS properties as they change throughout an animation or transition. Okay, now for the interactive part. Let's apply what we've learned so far and write some of our own animations. I've shared a link, either in the Zoom chat or the video description, that will take you to a page that looks like this. I have 3 short challenges prepared that we'll walk through together, but feel free to revisit this site and play around with making your own custom animations if you like. Let's start with the first one. The rotating square is what we're trying to create, and you can see we have a simple editor for HTML and CSS in the bottom left. We'll just be using the CSS one for now, but feel free to reference the HTML to see what the DOM element structure looks like. To complete this challenge, we'll need to define a keyframes animation, so let's start typing that out. I'm going to name my animation Spin, but you can call yours whatever you like. I'm going to start by using the from and to keywords and set starting and ending rotations of 0 degrees and 360 degrees. Now that we have a basic animation defined, let's add it to our square. And now let's run our code. As you can see, it spins, but only once. Let's fix that by adding infinite as our iteration count. Now that it's spinning continuously, you can see the dramatic effect that the timing function has on it. And remember, this timing function is going to default to ease. We want it to spin at an even rate, so I'll also add linear to our code. Okay, we're almost there. But to add the color change, we're going to change the from and to percentages syntax. I'm also going to add an in-between value at 50%, specifying a yellow background. And when we run it, we should see it's spinning smoothly and flashing between orange and yellow. Okay, now that we've done one animation, let's try using the transition property. This example is a fun 3D effect that looks like a flipping over a card when you hover over it. There's a bit of starter code for this one because of a few unique CSS properties needed that aren't widely used. The first one is perspective, which has been applied to the outer container element and will give our 3D scene depth. The other important property to note is transform style preserve 3D on our card element. This allows us to rotate the element in 3D space around an X, Y, or Z axis. You can also see that the back face of the card is currently hidden because of two things. One, its Y rotation is set to 180 degrees, so it's rotated away from us. And two, because the back face visibility is hidden. We're going to simply add some code to rotate the card around on hover and add a transition so that it happens smoothly over time. Now you can run your code and hover over the square to see what's hidden on the other side. I won't do this in the video so as not to spoil the surprise. Moving on to the last challenge, I thought it'd be fun to work with SVGs, or scalable vector graphics. SVGs are often animated with CSS because they can form complex, customized shapes, and they also have some interesting properties that let you do things like draw them to the screen. The first step here is to fiddle with the stroke dash array property. By setting it to a numeric value, you will notice that it breaks the stroke of the graphic into dashes, each with length equal to the number you specified. What we're looking for is a number high enough so that dash length is long enough to draw each letter, but not go too far. With a little trial and error, I found that 450 was just the right length to fill in even the M, which has a very long path to make its shape. Now that we have this number, we can define a keyframe animation to draw each letter in using a related property called stroke dash offset. We'll start the dash offset value at the number we found earlier and end the animation with dash offset at 0. Now I'll add this animation to each path element in our SVG and run the code. As you can see, the combination of those two stroke dash offset and stroke dash array values gave us a really cool, smooth drawing in animation. I'm going to leave the final adjustments up to you to get the words to fill with color and the animation to repeat itself. I hope you all learned something new today and that you'll consider using CSS animations in your next web application. Even though there are limitations when working with CSS animations, when done correctly, they have a strong visual impact and are relatively easy to integrate into your existing code base. The last thing I want to leave for you is a few links to check out if you want to learn more. There are hundreds of excellent tutorials out there for animation, so I highly encourage you to check them out.